All right. Hello, everybody, and welcome to Tech Weeklies. And this week we will be continuing from last week's topic about streams, and we will learn how to build a stream library from scratch. So go ahead, Jan.
Yes, thank you. Today will be completely live coding, no slides. I had a slides last week. So let's just begin, shall we? At the beginning, I really like TypeScript for something like this because of type-driven development. So at first, if I don't exactly, I'm not sure how to implement it, I just sketch out what I want as an API. And then the solution is often not that far away. So at first, you remember subscribe. Let's just write a function prototype. It took an object that had a next function where we could react on data, a complete function that worked when the stream ended, and an error function that was called when there would be an error on the stream. So let's put this in an interface and call it observer. That's just how RxJS calls it. It doesn't matter how we call this. So we have an observer that takes some data, and this data is of type T, and we do nothing with it. Error does not have to be defined, so we get any error. Also don't need to do it, and completion again is optional. It does not have any arguments because it just is a signal. So, hey, this stream has ended now. So then we can say, okay, subscribe takes, of course, an observer. So let's make this. And then we also need a type argument. So subscribe to some data of T. So we don't know what we return yet. So let's just put any date for now. Yeah. So subscribe now, we need to work on some kind of stream. So let's just add a type for this. Type stream. Stream carries data, so let's make it generic. But again, no idea what the stream data type will actually look like yet. So we just want to model this out first. We also saw in the presentation, I want to use a pipe function with this. So we have here then our source and then operator 1 and then so on until subscribe. This pipe function, we can implement that first. It's not a problem, it's not hard. So we can type it like this. We write a pipe function that takes a first argument and some functions. Again, the types are pretty general at the moment. So it takes an array of functions. Let's make this a bit bigger. And we also don't know what it returns. So at first we have this initial argument. And then for any of the function, we call all the functions in order. So basically repeatedly applying, at first we start with an initial argument, and then from first to last, we then call all the functions with, again, this argument and return then the final result. So this is just how, this is also how pipe is, for example, defined in Ramda or all those utility libraries. It's nothing special. The types are not that nice yet, but TypeScript doesn't have a nice way generically to say okay, this is the first argument, and then take a function from the first to the second, and then from the second to the third, and so on and so on. So we need to use overloading. And if you use TypeScript, overloading works like this. So we just specify a different type signature. So then we can say, okay, we have a type signature on A, and then we have a first function that takes this A and returns AB, and then the whole thing returns AB. And then we would need to write this again for the next, for 2 arguments, and then for 3, and then so on. But I'm using Vim, and Vim has a nice feature that's called macros. So I can just press 9, add, and I have made this on P. So I have a macro that just generates all those overloads. So now we have up to 10 arguments, this pipe function. But this is just so we get nicer types for TypeScript. It's not needed for our implementation. So if we go here, we have this pipe function now available. So now we would need some source. And also, if we know how the source looks like, maybe we can get some more idea how the stream actually will look like. But one thing we can notice beforehand is at the moment, like subscribe takes at the moment the observer, so what we want to do with it, but we don't take any stream yet. So we can be sure about that. It will take some source, again, returns whatever. So we can, again, in here, this is the source we will be subscribing to, because we know if we want to pipe here source subscribe some observer, doesn't matter. Then you see here, this first argument has to be the source. So a source will be a stream. So this A will be stream of something. And then we need a function from stream something to something. So this is what we have here. So this is then the function from the stream to the result that pipe will return. But now we need the source, because this stream type is still, we don't know yet what it is. So I will just comment this out down here. So let's have a look at the other side of let's write a periodic function. So we want to take an argument of the milliseconds, and this should be a source. So it just should return stream of numbers, whatever that means. So then how would in JavaScript in general you do something that happens every interval or periodically? Like there is only one real way to do this, and that is with set interval. So here we can specify our milliseconds, and then we do the thing here. But another thing we already know is periodic should count up. So let's start with 0. So do the thing will get I++. So then we can, every step we count up. So we now need to somehow push data from here to here. And as said, we can only call a function here, but we need to return something here. So one thing we can do is have stream be a function of to any. Well, because this way, now we want to return a stream, but a stream is a function, so we return a function. So let's return a function from observer to something else. Because now we have the nice thing here, this function that we didn't know about, like there is the observer, and observer has a function where we can push data downwards. So this is perfect for us. So let's just go here, observer.next, and we call I++. Nice, there are no errors more in our TypeScript. That looks good. So, and now we also have, down here, we know now that stream is again a argument, like a type synonym for another function. So let's bring that here. So the source, yeah, that's fine. But we can, source is now is a function. So let's, if we hover over here, we see, okay, it's a stream, but stream is a function that takes an observer, and we have an observer here. So let's just call the function. That also gets rid of the errors. And let's try this, shall we? So we pipe. Our source is periodic, let's say with 1 second. And here we want on every next, we want to just log it to the console. So I have here a terminal. Let's run this code. And there's an error because I made somewhere a mistake. Cannot find source. Because this down here. Here, that's our code. We pipe, and let's run this. And yeah, every second now, you see we get another number, and it goes on forever, exactly as we expected, because the stream of the periodic stream is infinite. So this will continue until I just abort it. So the first step of our stream implementation is done. That's pretty nice. Let's add another operator to build further. We want first, what is an operator? Let's add another type synonym here, type operator. An operator should transform a stream. So we should take 2 type arguments, and it's then a function from the first to another stream. So an operator is just a function from stream to stream. And again, as we saw earlier, a stream is another function. So we get already a bit deeper into this. Let's go with the simplest operator there is. Let's go with map. Map takes a function from some t to u, and then it should return an operator also from t to u. So what is operator? Operator is a function. So let's return a function from source. And now the second part is then, so source is this part, and we need to return this. But stream, again, is a function from observer to anything. So this observer we can also have here. So, and then we need to return and do something. As we saw earlier, we can subscribe to the source to get data. So let's do the source. But this time we don't want to pass the observer directly, because then we would just like pass the data unchanged. This is not what we want. So we need to have our custom observer in here. And for every time we get some data, we want to call the observer.next, because we need to pass the data. So this is the source. We get the data from here, and we need to pass the data down further. But we don't want to pass the t's. We want to pass the u's. So the only sensible thing we could do is call the function. So let's pass f of data. And again, TypeScript errors are gone. That's pretty neat. For the error case, we don't really need to do anything. So let's just pass in the original observer. Same for the completion. Map does not really care about that either. Yeah, here should be a comma. But we can also just make this a bit shorter with some object spread. So we take all the original arguments and just replace the next function. And again, let's try this out. Add a mapping function here, just double the values, something simple. Again, we don't get any TypeScript errors, and we can, again, hover over this. And we can say here, map is now a function from number to number, and it is an operator from number to number. So which is what do you expect? When we now use the string constructor around this and hover again, we see it's a number to string, and it's an operator from number to string. So this is what we expect. This is pretty nice. Let's remove this again. We don't need that. And let's run this again. And as expected, we get all the values doubled. So our stream abstraction seems to be quite solid. Let's go a bit further. Instead of having an infinite stream, I want to now limit the stream. I only want to take, let's for example, 10 data points. We can write a function for this, the take function. So let's write function take. That take should take a number, how many points of data we are interested, but it does not change the data. So it's an operator from the same type to the same type. So again, this is an operator, so we get the source and we get the observer. Oops, that's not what you want. The observer. And then we need to do something again with that. And we can just see what we did here with map. But we just need a variable. And then we can copy this and just paste it. But now we don't have a function, but the thing we want to do now is check if I is less than n. If so, we want to pass the data unchanged, so let's remove that function call. And we want to increase the I. So now it will start from 0 until our number and only pass the data for this. Let's include that in our pipeline. So after mapping, let's take 10 data points and run it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's nothing coming anymore, so that worked. But also our program is not terminating. So the node process is not terminating. So something is still going on. And the problem is what we have here, like this periodic stream, it still sends us data. We are just not propagating it further down. But this thing has never stopped producing data. which is not ideal because now I need to again abort this. So we need to include some termination. So we need to, from the downstream, go up and say, hey, I don't need any data anymore. I'm done. Let's check our stream type again, because how would we do such thing? We need somewhere, for example, we need to here. If you have here else, we want to unsubscribe somehow. But where, so some unsubscribe on the source. So where could the source give us such a function? It could return us such a function. So let's add another type synonym. And this type synonym is a subscription, which is a function that is just doing something. And then we said a stream should then return such a subscription. And we get some neat type errors again. So this is where we need to do this. So the first thing we can do, let's start with the stream here. That's where we actually want to provide such an unsubscription. And this unsubscription, so here, this function should now return this cleanup function. So here we need to clean up. How do we clean up? We want to kill this set interval, basically. And there's just a simple way. We get the ID of that interval. And then in here, when we are called, we can say clear interval ID. So this already would terminate this. Subscribe returns any. We don't need to really do anything here. That's fine. We could, however, this returns a subscription. So nothing would hurt us to just return that subscription out further. So let's do this. So this will also return a subscription. So our map operator now also needs to return a subscription, but we can just return that subscription from the earlier ones. Map does not take care of any cancellation or anything, so we just pass that down. Same way we pass down our error and complete handlers. Take is now the interesting thing. We get the unsubscribe function from the source, and once we are over the threshold, we unsubscribe. But we also need to provide a unsubscribe function ourselves. We don't really do anything special on unsubscribe, so we can just return the same unsubscribe to the downstream. And again, miraculously, our type errors are gone, and we can try it again. Well, let's use a little bit a lower number so we don't have to wait as long. And 1, 2, 3, 4, 5, and it completes. But you noticed that the completion was not instantaneous, so there was something missing. And then also, if I would now add here a completion handler, so on complete, please say we are done. We need a comma here. .log. Okay. If we run this now, we don't get this handler. So let's solve those two problems one by one. The first thing is we still wait until the next data comes before ending. This is simply an error here. Instead of checking here if it is lower, we should just always send data. And here check if our I equals the n, and then directly unsubscribed. So the last time we send data, we increase, but don't unsubscribe if it's so. We need to unsubscribe immediately after we send the data. So that's what should already fix the first thing. Now it should immediately terminate after we are done. Yeah, see, 8 comes and it's immediately terminated. So that's good. We don't need further data before the stream completes. The second thing is now we need to call this completion handler somewhere. And there's one very obvious way, like here, we are completed. So let's say, well, we have completed. If you don't know this syntax, this is rather new TypeScript syntax. As you see, complete is an optional method. So how you would normally do this is, if this is defined, then observer.complete, else do nothing. But for this, there's a special syntax. It's this question mark dot operator, and then we just call the function. So this, if complete is defined, we'll call the function. If it's not defined, it will simply do nothing. If we try this again, It will spit out the data we expect. And we are done. So nice. The whole chain of operators is now working as expected. So let's extend our vocabulary a bit again. As for the target where we want to go, we want to, I showed last week, I showed you this example program, the simple counter application here. So this is where we want to go. We want to have an increment stream that takes click events from the DOM, merging of streams, scanning, and then subscribing. So we have subscribe, we have pipe, scan is missing, merge is missing, and from event is missing. Scan is the most similar to map. So let's start with scan, I guess. Go here to map, just copy all the code, go here. So let's call it scan. The function now should be similar to array.reduce. So we first get an accumulator that's of type U. We get the current value of type T and return a U again. And we also get an initial value of type U. And then we transform T's to U's in the stream. We need to keep track of the current value. So at the start, this will be the initial value. And then down here, we need to update the current value with our function. And we give it the current value, but also the new value. So we have this fold, like array.reduce or something. And then we give this current value further down. Type errors are gone. Looks good. Let's try this. Instead of doubling, let's type x and sum. No, the other way around. Sum and x. And just add those. And we need a second argument. We start with 0. One thing we said, I said in the presentation, the starting value should be also emitted on the stream. So let's do this. Immediately here, we want to send this data. No, we are in the wrong operator. Sorry, here. Here we want to serve the initial value. So now immediately after subscribing, so this will be called when we are subscribing, so we have an observer, then we send out the current value, and then all the further value will come from the source. So down here we have the sum. Let's try this again. Now we have 2 zeros. Why? Because at the beginning we send out 1 0, and this also gives out 1 0. Let's just let this start with 1. So now the periodic stream starts with 1, and so the 0 then comes from here. Then it's easier to see. So it's the 0, 1, 3, 6, 10. So we are just summing up. So this is the 0. Then comes from here a 1. 0 plus 1 is 1. Then comes a 2. 1 plus 2 is 3, and so on. And then we get the output here on the right. So this is pretty neat. Scan already works. So only 2 operators to do now. Let's do merging next, because it's still one of the pure. Like this interacts with the DOM. So let's go with merging first. So to merge stuff, for simplicity's sake, we just merge streams of the same kind. Then we can just take all the streams that have the same data type and return a single stream. So if you're not that familiar with REST syntax, so this takes all the arguments and puts them in an array. And all the elements in the array will have this type stream T. So we take an array of streams and we will return a singular stream. So now we should return a stream. So a stream is a function from observer to a subscription. So somewhere here we return some cleanup. That's the first step. So now we need to keep track. We need to subscribe to all the streams. So let's do this. For let I equals 0, I is less than streams.length I++. So now we can go here, streams I, and call it with our observer. We want to, every time we get some data, we want to hand it out. But actually, we don't really need to do anything, because everything we would do here is just to call observer.next. So for this part, we can basically just say observer. So we pass our single observer from downstream. So this single stream, we pass it to all the upstreams. So this will automatically merge all the requests. The only thing we need to do now is some cleanup, because these return unsubscriptions. So let's create an array for that. This array will have the size of the length, and then we get it here. So here we fill those unsubscribed functions. And down here, we go through the whole array and unsubscribe from every type. So when the downstream unsubscribes from us, so calls our cleanup function, we will then call the cleanup functions on all the arrays. One thing is now missing still, because this observer, when one of the streams here completes, this observer will be notified of this completion. But this will lead if you have two streams, for example, and both complete, now this observer will get two completions. So a stream should not complete twice. So let's track how many streams have completed and add here a special complete handler. So here, every time we increase, every time some of the upper streams completes, we increase the number of streams that have completed. And if this number then is the number of streams we have in total, only then we complete the whole thing. So this basically says, well, we need all the streams we pass in need to complete, and then we complete. This is just so that every stream only completes once, if at all. So this is already merged. So let's try this a bit. We can merge periodic of 1 second with periodic. Well, let's directly put it into two different. So we have const stream 1, and we want to pipe the periodic. And we just to see what it's going on, we will take the x and say stream 1 plus x. And we just copy those lines. That's not what I wanted. So we copy those lines and have a second stream we can subscribe to. Let's make the interval only half as long, or maybe make it twice as long. Make it twice as long and say stream 2. So now we can see from where the data comes from. And then we merge stream 1 and stream 2. So, and here you see already we get an error because we are now shipping strings. So let's just delete those two. Again, we take 5. Let's take a bit more. We have now 2 streams. Let's take 10 again. And let's check what we are getting as a result. So first you get stream 1, then both at the same time. So if you saw, like, we always, this stream 1 happens double the fast as stream 2. So we get first one stream to 1, then those two at the same time, basically. Then one stream 1, those two at the same time, stream 1, 2 at the same time, and stream 1 again. So this seems to be working quite well. And again, we are completing. So this means once we are, like, once this take unsubscribes from our merge will unsubscribe from the 2 periodics, and thus the execution of the program will actually stop, which is what we want. So this is nice. So only one operator needed to go. We need to implement from event. With our knowledge, this shouldn't be that hard anymore. So let's implement function from event. It will take the event type, that's a string. And it will take some element, and it will return a stream of events. Normal DOM events you would also get with document.createListener, because that's also the only way. So we need to return a stream. So again, we get some observer at some point. We will get the observer, and now we should do something. And we should return in turn a cleanup function. So the only way we can get DOM events is we can take the element, add an event listener, the event type we already have. Now we need some listener. The listener, it will get the event and needs to do something. Yeah, we want to transport this event to the observer now. So there's only really one way. We just call observer.next with our event. TypeScript errors gone. This is nice. Now for cleanup, there is element.remove event listener, and it will take our listener again. Oh, it will also take the event type. So this will remove our list. So we clean up also after us the DOM listeners. And after that point, we will not send any further data. So observer.complete is in order. So we say, hey, no further data will be coming down your way. And now we have already everything we will need. So I will remove all this code here and just uncomment this one. It tells me that, yeah, because query selector might not return anything. So this says it's possibly null. But with the bang in TypeScript, you can say, hey, trust me, this will be defined. So this won't be null or undefined. Same here. This might be null and this might be null. But now our code does not give any compiler errors anymore. Obviously, we can't run it in Node now. So what I will do now is use parcel to create a simple, oh, we don't have an index HTML. Let's create a simple index HTML. So we need some simple HTML. And we said we need a h2. And we need 2 buttons because we have 2 buttons here, increment and decrement. Or we doesn't need to have to be button, just need something clickable, but Futurice will get angry with me if I don't use buttons. So let's use buttons. We need an ID on this button. That should be increment. And let's just use a plus symbol for this. And copy this. We call this button decrement, use a minus sign. Then we can close the body again, close the HTML. And this should be valid HTML. So let's try the build again. Nice, now we have a website running. So let's switch to a browser and open this website. So there's nothing rendered yet. Why is there nothing rendered yet? Because I probably forgot, yeah, I forgot to include the JavaScript. So let's include script source equals source index ts. So this is proof, like if I don't have JavaScript, there is not much happening. I can click those buttons and nothing interesting happens. So now I will include the JavaScript. You see on the right, it will rebuild, and now it will also compile my TypeScript for me. And if I now reload that page, I still don't get nothing for some reason. What does the console say? Oh, yeah, I did something funny with the, yeah, here, there's a $sign in here. That should not be the case. Let's go back here. Oh, now it did render something, so it automatically reloaded. So if I reload now, it's still, I loaded the same HTML, but now our current value is 0. Why does it show this? Because this will only emit if you click on the button. I have not clicked something, so those two did not do anything yet. Merge then obviously did also nothing yet, but scan. Scan sends out this initial value immediately. So this is where our 0 comes from. So then the 0 gets passed here, we subscribe, and then we change the text of the heading. So this is how, if I would drop this 0, then at the beginning, this would still show nothing rendered yet. But as yet here, we have this from event, and it will react to click events, and we map it to 1. And the decrement button, we make it to -1. So it works as expected. That's the first counter. So, and that keeps working. That's all the code needed. So this is the whole description of our app. We have an increment stream, a decrement stream, then an accumulated value stream, and then we just print out this value stream. And for the rest of this live session, like, this is our business logic, and the rest of our coding session won't touch the business logic. So this code also shouldn't change, because we don't want to do that. What we want to do now is, as said last time, I want to bring in translations. So at the moment, our app is only in English, and this is not acceptable. So let's translate it into other languages. So for now, we need a library that I will use for translating stuff. I haven't used that library in production yet, but from looking at it, it looked pretty okay. It is A18 Next. I think that should be the standard and for front end. So let's import this. The thing is, if we look at the documentation, there is let's go back to our actual app code, not our library code. Here, there is i18next.init, which we need to call within config object. But this will return a promise. You see here, it returns a promise of a T function, and this stands for a translation function. So, and we shouldn't use that. So we can access this T function also without the promise. So there's i18x.t. But we shouldn't use that T function before this promise is done. So we should wait for this promise to resolve first. So let's just make it a promise. So this is the init promise. And let's also initialize it properly with some stuff we want here. Let's just copy my translations that I acquired. Here, let's put them in. Oops. Again, use the wrong copying here. So now I just added some resources for English, German, and Finnish. What our string should say now, including interpolation. That's just provided by i18 Next. But now we should wait until our promise, so our translations are initialized, before we either render anything, but also before we just react to it. So we need another function. We need to convert a promise into a stream. But this is not hard. It should work similar to from event. So let's just call it from promise. We will give it a promise, and we need some type. So we will get a promise of T, and we will return a stream of T. So every time we return a stream, we will get as argument an observer. Okay. The promise provides only 3 methods, so there's not really what we can do. So then we will get some data. And there's only one way we can send that data. We want to send that data to our observer. But also, a promise will only ever resolve once. So at that point, we can already say, hey, there won't be anything else. So we complete at that point. Promises do have some error mechanics with catch. So at that point, we can tell the observer, hey, there was an error. And TypeScript now complains that this needs a cleanup function. But promises are not cancelable. We can't do anything with the promise. We can't clean up the promise. That's just a limitation of how promises in JavaScript work. That's also why I don't like promises. So the only thing we can do is do nothing. So we give a no op back. Now TypeScript only says, hey, you're not using from promise, but we will. So we have a stream that is concerned with our language. Oh, by the way, I always use this $sign to mean stream, because language stream is a bit, yeah, if you do this for every stream, it gets annoying. So language dollar is my abbreviation for language stream. We need to pipe some stuff together, and the source is we convert this init promise into a stream. So now we also want to change the language. So we need to adapt our index HTML a bit. Let's add a select element. So we get a nice drop down where we can select the language. And we have one option that is English and another option. Let's just copy this. This will be German. And the third option that will be Finnish. So Parcel already built this. So if we go here, we now see our drop down already. So we have just a simple drop down that let us select our language. So once we have initialized our thing, we then want to listen for, so after this completed, we won't get anything. We won't use the translation function yet because we want to initialize it with the language. We need to listen to our change events on this element. So query selector on, yeah. Now we need to name our select element like this. So it will be found by query selector. But the problem is now, if we look at the type of map, it is an operator from the T function. Okay, that part is ignored, but it returns a stream. So it returns a stream of streams of events. We need to flatten that. So now comes also the probably most complicated function we will write. Flatten. Let's put it above here where our library part is. Here's our library part. Flatten. So flatten will take the source, which will be a stream of streams of T, and it should return a simple stream of T. So we want to flatten the stream. Again, we return a stream so that we will get an observer as argument. And at some point, we need to return a cleanup function. So what do we want to do here now? This source is basically our outer stream. Like this is a stream of streams. Let's subscribe to that. We need to subscribe to the outer stream to get to the inner streams. So that sounds like a reasonable thing to do. So next we will get our stream, which will be a stream of T's. Good. We can here now subscribe to this inner stream. But we need to keep track of the subscription. So let's make a variable here. And this will be either a subscription or it will be undefined. And so here we keep track of that subscription so we don't lose it. So at that point, we will get our data. That's the thing we want. That's what we want to send out. So at that point, we can just tell, OK, observer.next data. Now the more complicated part. What happens if we get a second stream? Flatten should switch the stream. So this should unsubscribe to the inner stream and subscribe to the new stream. So what we need to do here is actually call unsubscribe on the old stream. So this is either undefined, then nothing will happen, or we are already subscribed to a stream, and then we will unsubscribe, tell him, hey, I'm not interested in your data anymore. You can clean up or do whatever you want. And then we subscribe to the new one. Now the next thing is what we need to take care of. So errors are pretty simple. Errors, we just simply don't care. We just pass them over to the observer. Same for the outer stream. So errors on the inner, so this is our inner stream, and this is our outer stream here. So errors are just passed down. Now completion, that's the last part missing. Completion, we need to, it should work like this. So if the outer stream completes, but we still have an inner stream, this inner stream should continue until that also completes. So we need to keep track of the completion status of the outer one. So now here, if the inner stream completes and the outer stream also already completed, then we will tell the observer, hey, you will definitely not getting any new data. And yeah, that's basically all we have to do. But if we only complete the inner one without having completed the other one, we don't need to unsubscribe because complete already says, hey, I'm done sending data. So we just need to say just need to remove this. So if the outer stream completed, we say we are already completed. If the outer stream has not completed, this is it. And if I'm not completely done yet, no, this is fine. Looking at my thing. So now we just need to do some cleanup. So if we say, hey, please unsubscribe to everything, we need to unsubscribe to the outer stream. So this is our outer stream that we unsubscribe. And at that point, this has completed. So then we can say our inner sub, if it's defined, also unsubscribe from our current inner stream. This is basically our flatten function. Let's try it out. So down here, we have now a stream of streams. And if we call flatten here now, oops, we need a comma here, and hover over the type, we see it will flatten and we don't get any errors. So if we have another map down there, here, map, now we want to get the events. So here, that's the events from here we want to get now. And let's do nothing with it. If we hover over this map, you see we will get just the plain events. If we remove this flatten, we will get a stream of events. So this works. We will get here just plain DOM events. So also TypeScript autocomplete has here all those properties that we want. So let's go with event.currentTarget, but it does not know that it will be a select element, and we want to get its value. So this will give us, every time we change the language, it will give us this value here. So the language code for the language we chose. At the beginning, we want to start with English. We don't have start with yet, so let's just define it. That's a very simple operator. We need some initial data and return a operator. A operator. We don't change the types. And we get a source. We get our observer as all operators look. And then at that point, we can say, okay, we want to start with. So first we should give it our data, but then we just, from then on, we give control over to the source. So this basically start with our data, then do just the same thing as the source would do. Nothing special. So now this also completes, and we will get now here, if we hover over it, it's a stream of strings at that point. So at that point, we can get our language. And there is a function i18next.changeLanguage. Again, that returns a promise. So we need to wrap it in from promise i18next.changeLanguage. And we want to change to our language. There is a comma needed. So, and again, then we have a stream. You see here. We convert strings to streams of translation functions, but we want the raw translation function. So at that point, we need another flatten. And at that point, if we look at language stream, you see it's a stream of translation functions. And from what we defined, it will always be the correct translation function for our language. So we don't need to care about which language is currently selected, because we will always get the right one. So our business logic, again, should not change, but we need both. We need the value from our business logic, and we also need the translation function from our language stream. But we have not yet defined combine. So let's go with combine. And you see later why I put it here. So combine takes, again, same as merge, some streams. And other than merge, we can't type it nicely. And it should return a single stream of an array. So where merge puts all the streams in just one stream, combine will put them in every data point in an array before presenting. So the implementation of this looks not that different from merge. We take the observer that we get because we return a stream. Observer, thank you. And again, we need to return some cleanup. So here, we need to put out some data. Let's just put some nice types first. So again, just like pipe, we have to type this manually. So we can say here stream 1, stream of A, and stream 2, that's a stream of B, and this will return a stream of A and B in a tuple. And because I already prepared another macro, this is just requires me, let me check which character it should be O. Yes, I put it on O. So I press 9 at O, and I get all my overloads again. Really handy. I can say you Vim is really handy. So now we have nice types, and we can also see like how this works. So we have streams A and B, and we emit always the together. So we need to keep track of these together values. So let's create an array that is the values. And we need to see, because combine should only emit once we have at least have all the data from the streams. We need some marker. And the thing is, I could now use undefined, but what if a stream sends undefined? So there's a handy little trick. We use a marker, and this marker is an empty object. The reason why is because this object, if you compare objects with equality, they will check if it's exactly the same object. If an empty object is the same as an empty object, this will return false, because those are two separate objects. They are created individually. So no data can be equal to this. So this is what we use here. So then we just fill this with our marker. This marker says, hey, here's no data yet. From then on, we need again to go through all the streams. So for let I equals 0, I is less than streams.length I plus plus. And we need to keep track of the subscribe functions. So let's have the unsubscribes again an array streams.length. So unsubscribes I equals streams I, and then we call it. And now we need to do something with the data we get. First, we check if our values thing is still our marker. So we have not. So basically, this means it is the first time this stream sends data. Then we count. Okay, we have now one more data, and say this is the data. Wait, this should happen always. And if we have exactly the same amount of data as we have streams, so if this means every stream has at least emitted once, at that point, we will send out the data to our downstream. So values is our data. So our error function is not interesting. We will just pass the observer.error. Completion, again, we need to be a bit careful here because we need to wait until all have completed, but we can again track this with another variable. And just count it up. And again, if num completed equals the size of our streams, then we say, hey, we are done now. Okay, last thing missing, cleanup for const unsub of unsubscribes. We unsubscribe. So this unsubscribes from all the things. This should work now. So now, again, here we have this combine function with tons of overloads. So we combine the value stream and the language. And if you know, check here on the X with some hovering, we see we get a tuple of a number and a translation function. So as said in the demo, we get here translate. We can destructure, and we need to change our presentation. So the text content is now not our English version, sondern it's translate. Our key is current value, and we have something to translate, to interpolate. So if we, because as you see here, like this interpolation is what we pass in here. So it is rebuilt now. Let's reload and check. So our counter still works. Let's check the translations. Oh, it's German. It's Finnish. Back to English, Finnish, German. Everything works. And we didn't have to touch our business logic at all. So only thing we added a new stream of data, which is our translations. And then, of course, our presentation changed because obviously we added translation, so our presentation will change. At that point, I would cut the presentation. I could continue and show you that it will indeed do the lazy loading I showed in the last week in the presentation. I will share the code file with you, then you can see it. Like I will add the lazy loading now myself quickly, or wait, I can just copy paste it from my preparation. So let's go here. I have copy pasted. I can copy paste this. So now when I lazy load translations, I don't want either the business logic to change or the presentation to change. The only thing that should change is how I get my translations. So I can paste a big chunk of code here. Let's remove the old code. So in the example, I said I will use a HTTP request, but I just simulate an HTTP request with set timeout. And we will have a really bad connection because it takes 2 whole seconds for the translation to arrive. Yeah, language stream, I need to delete the other one. That one should be deleted. That's the old one. So this is the new language stream. Again, it would now take too long to show this, but we start with just the English translation. And then every time we already have the translation, we just do nothing else. We get the translation from HTTP and do some flattening. And again, I have not changed either the presentation or the business logic. Let's save, let it rebuild the site. Yeah, this is from reloading. So now, if I now will load the German, you see it takes 1, 2. Oh, it doesn't do anything. Do I have an error? What did I do wrong? What did I do wrong? I have this. Let's just try reloading again. If I switch to, come on, finish. Oh, I don't even, I have added, so something is really fishy. Language stream. I next is, where's the error? I copy pasted this, there shouldn't be an error. I combine the language stream again. Okay, that's probably the demo gods because this was working yesterday. I'm not sure why it does not do anything. We start with English, so Okay, for some reason, it does not like this. Let's just try rebuilding again. And then reload completely. If this makes a difference. 1, 2. No. Okay, for some reason, this is not working anymore. It worked yesterday. I need to check probably because some differences in the live coded version versus the prepared version. I can show you if I just change the import in the HTML to index 0. This is the version I prepared. It looks exactly the same. 1, 2. It's English. 1, 2. No, nothing. Still not. Okay, I have no idea what's wrong.
Something going on.
Yeah, but I need to check and then I will tell you what was the problem. Anyways, thank you for listening, even though I used a little bit more time. But I hope this was interesting and I will share the code later, the working code. Are there questions now or probably better later in Slack because we're already over time? So yeah, feel free to ask in Slack.
Thank you, Jan. This was super interesting.